Okay, so we are starting. Data visualization is very important part of ML, machine learning, or deep learning, or whatever. It is actually data analysis and data representation, which is very important. How you represent your data. We'll be using Matplot or NumPy. We can use, or we have other options also. We'll be seeing that. So Matplot is a module which we have with Python. And in this, we have either PyPlot API or object-oriented API for more access to the backend layers. So you can have better visualization also. We'll see that how we are going to do. And I'll be taking sequentially what the things have to be done, because if I just take the theory, then applying that would be difficult. There's no theory. I don't believe in theory in computers, machine learning. Theory is from practical only. So you have to see the things practically, and then we'll see the theory. So we'll do it, whether it is lab or whatever. We are doing practically everything to see how the things are applied. That is a better way of understanding. Okay, so as far as the syllabus is concerned, so we have done almost half of that as far as theory is concerned. But we'll be doing in detail later the theory part. But application is more important. So at the end of the course, you should be able to apply at least and run the codes on your data sets. So this is the aim, and that is what it has to be. Okay, so data visualization, we'll see. We have to import Matplot, and we will be doing it now. So import Matplot lib. Okay, so import Matplot lib dot pyplot as PLT we normally use. So it will tell you if there is some mistake, but it doesn't have any as far as this is concerned. And then we need a NumPy also. Most of the time, NumPy is used for mathematical computation and arrays and all. So we'll be using that also. So now we'll be putting import that and then just create something. Import NumPy as NP. These are the standard things. As NP, it could be anything. You can use anything. Normally we use this. Okay. ELT dot subplot. That is if you want to have more than one plot in one window, but we are not having any as of now. And we can have the data equal to, at least I can have something like this, or I can directly put also. I can simply plot it, or I'll do this in the next one, where I'll create the data set and then I'll plot it. So let's see. Matplot lib is inbuilt in Collab as far as I know. So let's run it and see. If it is not, then you have to install it. It's as simple as that. The first time when you run, it is always slow, as you know. Collab would be a little slow, but then it picks up. Okay. This is a straight line we have 1, 2, 3, 4, 5, 6, 7, 8. Obviously, it has to be a straight line, right? 1 and this is 5. Okay. So x-axis and y-axis. This is for the x and this is for the y. You can see that. And figure and axis actually it is a handle which is required to plot. So ax dot plot, and we have plotted on that. We'll see that how figures and all everything has to be used. So this is a general thing. Now I'll generate the uh, data using the NumPy. X is equal to in NumPy dot linspace. I'll be using line space, linspace. We have seen this already, 0 to 100. 0, starting from 0, step to up to 100. Let's print it. Step by step we have to see. Okay, so data is generated. You can see that starting from 0 and 2, you can see 100 numbers are generated. These are 100 numbers. You can have a look at the size, length, and everything. You can see that shape also if you want. We'll come to that also. I'll be taking that now. This is this object-oriented style, so I'll just paste because I already have that. Okay. Typlot.figure to create the figure. So we have in object oriented. Now create a figure and an axis. This is figure and axis. Subplot as we did earlier also, and now we are going to plot and see why we created the axis and why we wanted to have that, because I want to have more than one data on this. So first is the linear. I'll plot it and show you. This is the linear which we got earlier also, so the straight line. Now I'll have to take it actually to the next one and put more. And then we have quadratic and cubic, and then we can label that. Okay. So this is x square x cube. This is quadratic. Plot more data on the axis, and this is cubic. So let's plot it and see. You can see the data is there now. Now we don't know what is what. Here we know that blue one was linear actually, but we don't know what these two green and orange are. So what we have to do is we have to put some axes and some legends. Legend is it will take automatically. So let me plot it again. You can use the final code. Now, final code, I'll just put the final code. Final code. Use it directly also. So first I'll have to set the X label, Y label, and the title and the legends. So let's have it. X label, set X label, ax dot set X label. You put X label here or whatever you want to display. Add X label to the axis and Y label to the axis. That Y label. You can put the text you want. I'll show you. Then you have to put the title, which comes at the top of the plot here, and then the legends. Legends you want to display. Okay, so what these colors mean. So let's plot it and see. Yes, it has come. Your title is here, linear, quadratic, and cubic plot. Then we have put Y label and X label. We can change that, and you can put whatever you want here. And then the legend, ax dot legend gives you this. Now you know that blue is your linear, orange is your quadratic, and green is your cubic. So now you know that what is what. So the moment you have the legend, and you can actually place the legend where you want. Also, you can move the legends, but for now, we'll be putting it here only, the default value. Okay, so it can actually find the space, and then it can just place itself where it wants to. All right, now this is a simple plot which we have created using a linspace.
Sir,
Yeah,
sir, for plotting the X label and Y label, can't we just type plot X label as some name and Y label as some name?
you can give
That's
a name, na? That is what I said. You
no,
can give
sir.
any name. 1 minute.
Here
You
we
want to say here, na?
yes, sir.
This you can change, na?
No, no, sir. Here we have written AX set as X label as something, and AX.
No, 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 no. This is a command. This one, na? This
Yes,
I
sir.
can't change. This I can't change. This is a command.
Okay, sir. Yesterday we have written just plot X label so and so, plot Y label so and so for pandas in the pandas
So
problem.
we are not using pandas, no? We are using matplot. We'll come
Okay.
to it. We'll come to it. We can do that. We can
Okay.
use numpy also. We can use pandas also. We can use numpy also. That is the placement you have to give where you have to plot.
Okay, sir. So
We
it
can do that.
okay,
Yeah,
sir.
yeah,
So
yeah.
it varies on depending which we import, sir.
Yeah, it depends on the module. Yeah, it depends on the module, which module we are using. So
Okay.
according to the module, it may vary. It may change. But this is
Okay.
very simple. Na? Actually, we have already have the axes AX.
Yes,
So
sir.
on AX, if I tell that this is the X label, this is the Y label, it knows,
Okay, sir.
right? You can use
Okay.
other Ys also. No issues.
Okay. Thank you, sir.
Okay. I'll just make it capital. You can see that. So that changes, and yes, we'll be using other also. So you'll see that. Now you can use again import, or you can simply plot using other options. One minute, I'll just Mm, I'll show you first, and then you'll know. I'll explain it what I'm trying to do. We have different options to display the figure or not to display the figure. This is similar to what we did here. Okay. We have off and on option. We can show also. So we have matplot pyplot.eon. So it enables interactive mode. Okay. I'll show you. I'll just put it here. Enables interactive mode. Now we have off option also. So if I plot it with that, so you have to switch it on. And 1 minute, I'll show you. Okay, I'll just copy this. And now I'll be putting it off. This is on, this is off. It's only that the interactive mode is off. Okay, and the figure will definitely be there. Right, so you can use this also, and we will see some more examples. You will know that what exactly we are doing. We have to see whether it is interactive or not and all. So you can see. So you can see the information also. You can get the information also. You can just put it off also. You can do that. Okay. So we have different options, but usage actually depends what exactly you want to do. I'll show you. Oh, it's off. Let me put it here. Code. All right. First, I'm just running it again, and now I'll be running this. There's no display. Now there would be no display because it is on the other axis, or you can say other code window, you can say. So what we do is we can use GCM mode, or we can just put it off, and then we can draw also. So what we can do is was interactive test. And now we have a GC option also. We'll see what is GC. Where is the code here? Just write what it is all about. Okay. We have to get the current access. You see this is a handler actually, which we graphical handler we use, and to get the handle of the plot, that with the figure you can say, and you can have the plot as it is. So that is not something new we do, but if you have the handle, then you can use something like plot.draw. Use plot.draw function. This won't do anything. Just display that figure size is this. Even if you run it again, it won't show anything, right? But I use the interactive mode off, and then I plot it something like this. plt dot interactive off. Then I in range 3 plot plt dot plot np dot random rand 10 plot dot show. So plot dot show also we use sometimes to show the plot. So you can see this. These are the different plots which are created. If it is interactive mode is off, then new plots will be created. There are 3 plots which are created.
So could you explain this one?
I'll show you and then explain it. You will
Okay.
see.
Okay, so
This is off now. This is off. I'll switch it to on, and then you'll see the difference.
okay, so okay.
This was interactive mode is off. That means new windows will be created. This is on. Now when it is on, then there will be 1 minute. I'll put the data properly. I've not. Oh, I've put plot.show in the same line. 1 minute. Plot.show has to be here, not here. Here also. Here we have to put the plot.show on the left side. In that case, it's okay. That was okay. That was when we were plotting and everything. One here. I think intents are okay. Let's see. Yes. So once you generate the data and we say plot.show, then you can see that when it is off on, interactive mode is on, you can see that one window you can see all the plots. But you can put legends and all, you can see what is happening. Okay, so you can generate it like this also, and even if it is off, and if you put the plot on the right hand side, left hand side, then also this one. So it all depends on where you're using plot.show. You can have interactive mode, and you can have the it is on or off, and you can check that whether it is interactive mode or not. I'll put 1 minute. Yeah, the plots are little different. You can see that the same data, different plots. The reason is it is random data. Okay, so these are random data which we are using, and that is why it is different. Let me 1 minute. Just put something here. I'll put the text here. Okay, so the matplotlib can be used in interactive or non-interactive mode. That is in I off or on. In the interactive mode, you have the display, which is after each statement. That means if you want, you can display like the one I have shown you in the example also. And in non-interactive, actually, the graph does not get displayed until the last is executed. So let's see whether it is actually true or not. Sometimes things don't work. Like here, I have shown you this is on. Okay, so it should work. It is off. And plot last if you're plotting in the last. So if I plot in between, so it according to it there should be all displayed, and that is what it displays. Yes, it will be in between, so all will be there. And even if it is off, it is coming only when we plot it in the last plot.show. If I put it like this, plot.show plt.show, data will be but we don't have anything here to show. You can see I'll have to get the data from here. I'll have to run it. It is already on, so I don't have to switch it on. The random values can be any. So that's why the graph will be different. So not interactive, non-interactive modes we have, two modes we have, and we can set them and check also. Okay. You can check whether it is interactive or not. It will return true or false if you're checking. Okay, we'll come to that. I'll show you 1 minute. It is on. No? Interactive is on. Already on. One by one, I'll show you. Interactive is on. This is line graph we already did. Then we have some more axes, and we just put the labels and see where the label goes. You can see that it is empty. Okay. It should actually carry the mode. The data should carry the graph actually. Now let me, this is on, already on. ELT dot on. Let's make it off. Let's see. Off. Plot will be there. Now again the data is not there. It should come actually. Using PLT. Yeah, we're using PLT only. But it is on the other window. It should come actually. The data should come when you're using the interactive mode. So it should come. Let me try one more line and see if it works. One line it will work definitely. If entire data is in one line, it will work. But it is not working when it is on separate lines. So if I put it all together, this one, then the titles and the plot. Next. Then again the plot. Then it should come. Let me put it here. Now it will come. On separate lines, on separate command windows, actually it resets, so it won't. But in this case, it will. Whether on or off. So this is interactive mode, and you can display that. You can check it also. Is interactive. That will return Boolean. Okay, it doesn't make much difference to our plotting when we are using the plots. So it doesn't make a difference whether you is using interactive or non-interactive mode. Anyway, now let's have again. We'll just import again, just to reset, nothing else. Input numpy is NP, matplot pyplot is PLT, and matplot library is MPL. We'll be using MPL now and see how it gives you the display. Okay, without NPL also you can see, and this also. So we have to generate some data. We'll be generating a data. This is the data, random data I have generated. So now I want to see how it is. I am going to plot this. Before that, okay, runtime parameters we can use here and plot also. So let me first have more data. This data can be anything, right? Just generating some data. Now we have AY and print. These are records. So if I print it, so it will just run away. Anyway, doesn't matter. You can see this data. Otherwise, you can see here also. a huge data set. You can see that the dots there. This was what was generated, and this is what is there now. The random numbers are generated, and again, if I print by here, see what we get. This one, it will be different every time. Random, random, random. So it is a random file. So it will just be different every time I run. So we are having we are not fixing the random. You can fix it using a random seed. We have option, seed option. We can fix so that every time whatever random returns should be same. I am using to get that. So if I want to actually runtime parameters, if I configuration, if I want to retain, so I can use the RC parameters and check how it works. So I'll just put something here. So there is a package which we have already MPL we have already called, so you can use that and have you can fix your settings. So if you can dynamically change the default runtime configuration, so you can use this command, and this is there already. So what I have to do is I have to put mpl.rc parameters. Path simplify is equal to true, and then we can have path simplify threshold is 0.0. So what happens? And we'll see that. First we'll plot and see, and then how. And I'll change the values, and then you'll see. This is one plot. You can see that the starting is -1 to 20, and this is 0 to 10,000. That is what was there. Okay. The threshold is 0.0. 0.0. Okay. 0.0 is the threshold. You can see the data. Now, let me change it. And see. This is the other window. Now it is 1, and you can see the data also. The threshold value is now path simplify threshold is 1.0. Size change, actually there should be 1, and this is 1. Let me change it further. This is not actually visible. There is no visible change, but there is okay. We don't have between 0 and 1 only we can give. So we don't have an option. The threshold values you cannot increase with more than 1. So this is either 0 or 1, or I can do one thing. I can use the other command. I can use line width command also. Ask the parameters, and I can use the line width command to manage my line width of the lines. I'll do that. It will be more attractive. So this is not visible. It is true. Threshold is 0. It is not visible. So let me show you some other things. We have already imported, but just in case, these we don't require. Declare also we don't require, but that's okay. Line width and the parameters and random we are generated, and then plot. So what we are trying to do is we are changing the line width and the line style. So we already have the data, so I can use this also. And let me see, but it won't be visible. Let me run it first like this. So the width also, and you can see it is a dashed line now. I've changed it. So in runtime also you can change the parameters if you want to change. That is available otherwise also. Just one more example. You can change to whatever width you want. Okay. So this is okay if you want to set to the parameters. So let's have some more meaningful plots. And we have the codes with me, so I'll just put it. Whatever the theory is, I'll explain it also later. I can put it. See, now this is a plot we have. This is red 0. Otherwise, it was a line plot. You can see that. Plot.axis 0, 6, 0. This is axis we have changed from 0, 6, 0, 20. So you're putting the axis as 0, 6, 0, 20, and you're just showing that 0 to 20. You can see this. Okay, so it can be a red, green, whatever. This is R is red, and O is what you are giving circle. So it can be different, right? So you can put any type of plot here. You can have a line plot. I'll just put it R without anything. What happens? I normally copy and so that I can retain what I did earlier. Otherwise, you won't remember that what we did. So this is red only, but now the plot is like this. And remember, now why it is a dash line. Remember this I have already changed line width and line style. I have already changed this. So if I don't give anything, so it will be taking my default runtime parameters. So that's why it is a dash line. Otherwise, it will be a straight line. Let me show you. If I just give one dash, see, and what happens here, right? So although it was applied here, but it was carrying on. So it will carry on to the next also. That is why it is runtime. So when your runtime parameters are set, so your plots will be a little different. Okay, we have now range. We will just time interval plot we'll have, and in this case we'll have a data which is using NumPy, and then we'll plot it. I'll show you a few things here. Yeah. So np dot range, a range 0, 0 to 0.2, and with a step of 5 we have, and in on dashes and all plot t is a data tt, then r dash dash, then t into t, that is square, blue, then green. And you can see, let me show you the plot first, then I'll explain it. You can see that blue squares, bs squares, green, you can see the triangle type, and this red was dashed. You can have like this. So we have plotted more than one thing. Actually, x-axis, y-axis we normally give. This is one. This is one line. This is the other one, x and y. On x we are using t. On y we are using t square. And this is t cube. Green. Right? We can have like this also. The plots can be like this also. So more than one value can be plotted with the different lines, different colors, different symbols also, right? Just to save time, I'm just pasting because I already have the codes with me. I have already run it. It is there on the GitHub also. So I'm just using my data so that I don't waste my time in typing. We covered a lot of things are there. Okay. Now we have data something like this, like a dictionary. A np dot a range. On C we have np dot random integer 0 50 50. Then D numpy dot random 50 ka. Now data B is data A plus 10 into random and data D. 1 minute. Let me show you the data first. Then I'll put it. Otherwise, you won't understand what that I'm talking about. Problem is that I have to take few more things before I can actually take this. These data plot is okay, but I have to explain numpy and all also first. Arrays, so we have already done. See this data. A, C, there should be B also there. No, there's A, C, D, and D. You can see the data. Now, let me put it. Now, I change this. I can show you the data I have already displayed here. Now you can see what I'm doing is I'm saying that data, whatever is in data A plus 10 into random of 50 to be added in data B. That is, it has to be changed. We don't have B actually. We don't have B here. So we are adding B in between and D we are changing. Okay. So let's see. The data in the plot will be there. So now we have A. There has to be C, D is there. B has to be there somewhere because it is all mixed up, so I can't show you. They should be there. Since we have changed the data, it should be there. But anyway, you can see the plots. You can see that entry A, entry B, there are two plots. And the plot is A, B, C is equal to C, S is equal to D, data is equal to data. It is a scatter plot. Okay, we are putting a scatter plot here. This is commonly used actually for clustering and all. We use a scatter plot most of the time. That is for clustering basically. And the syntax is, I'll have to put the syntax also. I'll put the entire syntax. I'll not put the syntax, I'll just put the syntax there. It has X and Y, then S. I'll show you the parameters we use. There's a lot of parameters actually with the scatter plot. But anyway, I'll have to show you. Let's see here. Just putting it like this, I'll do the corrections. I'll do the makeup of this text later because if I do it now, it will take time. But the parameters are like you have, I'll explain it. What we used here, I can explain that. S is a float or array like shape. S shape, S is for shape, okay? Optional है. You want to give, it's okay. You don't want to give, it's okay. Then we use C also. 1 minute, what all we use? We use C. I've given here. We use C. Yeah. So shape was D, and C we used. Yeah. We use C. That is a list color what exactly color we want to use, and we have different colors options here. We have Y, and we have RGB. We have 2D arrays. We have the codes. Then we have the markers also. If you want to give any markers, we have different things. I'll put in a proper way the document, but you can see that we have other options also. We have CMap, normalization, vmin, min, vertical max, alpha, line width, edge color, plot, no infinite, and data. Okay. The different options we have for plot, scatter plot. But for now, I have put that there, but it has to be little more clear. I'll put it, but I won't put it now. It will be, if I adjust it, it will take more time. So let me just show you the plots first. If you want to have more than one plot and you have some values, so let's have that. We have some names and plots. Categorical plot, something like categorical plot, category wise plot. This I'll clean and clean it and put. Now if we have something like names, group A, group B, group C, then values 1, 10 and 100, that is group A, group B and group C. Then plot figure, and figure size is equal to 9, 3. Now this can change, okay? I'll show you. Subplot, this is a very common feature which is used in MATLAB also. We use in MATLAB also this plotting size like this, and in Python also 131, 132, 133. It is the dimension actually. We have 3 here, okay, and is the height. So scatter again plots. Let me plot it first and show you how it is coming. You can see the 3 plots: 131, 132, 133. Okay, that is, this is the first plot, this is the second plot, and this is the third plot. And 3, that is, you're giving the size also. The data, it doesn't matter. Data can be anything. It's just a plot. And how you can do it is like whatever data you have, you can use the figure size and 9:3, 9/3, or it can be anything else also. Let me change it to, let's say, 12/3. It may give an error if it is not equal. You can see that the width has increased. Okay. Let me change it to increase that 6. Now what happens if I give 6/3? You can see that it has reduced, and when I increase the width of this, it cannot be more than the size of the area. Yeah? You can see this. The width has increased. So 3 plots, you can say 15/3. This is 15/3. 3 is the plotting area. So we have 3 plots here. One subplot 131. You put names and the values. Names and the value, group A, group B, group C, and you can have the values are here 110, 100. It's the same actually. One is the bar plot, one is the scatter plot, one is the normal plot. Right? So all the 3 plots in one line, in one figure, you can say. So you can have more than one plot in one figure also. And for that, you have to see the size you have. And you can actually change the size. Like if I have plot.figure, okay. This was 131, 132, 133, and now it is figure is 1. The plot subplot is 211. First subplot in the first figure, then the second figure in the first figure, and a second figure. That is plot figure 2, plot figure 1. This is 1. In figure 1, 211 and 212. Then we have plot dot. We have already plotted. Okay. Now in figure 2, we have 456 plot, and then figure 1. Again, we want to have 211, and you can put the other plot. Let me show you and then explain it. It may be a little confusing sometimes. You can have 3 plots here. Easy as 1, 2, 3. This is the last one. Easy as this is the title actually. So first figure subplot 211. This is the plot 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. The other is 456, which is 456 here. This is different. This is 4.00. And the other one is this one on 211. So you can have different plots. Figure 1, figure 2, figure 3, you can give that also. Area is actually, it is area actually. On figure 1, you have 2 plots. On figure 2, you have 1 plot. And then again, you are calling figure 1. That is your current, and 211 still the current. 211 is the current. So on, you are just putting the title there. Okay. This one. 211, you are putting the title. You are calling figure 1 again, and you are putting the title. Now, suppose I change it. You will know the difference if I change it, but I won't change it here. Otherwise, you won't understand. You must be wondering you can do using Excel. But normally in papers, we don't accept. We won't accept that. If it comes to me, I'll tell the person to plot it using the code. If the paper comes to me, I won't. As a reviewer, I review papers in transaction journals. I have 3 journals: SCI, 2 SCI, 1 Scopus. So I'm a reviewer there. So I would not be accepting the paper if it is an Excel thing, because anybody can plot from there. Okay. So what I've done is I have changed it to 2 instead of 211 in the title. I have changed it to 212. That was the other plot. So you can see that the title has gone from this one and gone here. It has merged because there's no space as such. Otherwise, you can see that it has gone there. So title, it depends. So you have plotted actually figure 1, figure 2. These are actually the areas. GCA, that is what we call graphical area. Normally we call it, and those who have used MATLAB would be knowing what GCA is. But GCA is actually your graphical area, the area you have on the canvas. So on that, I have figure 1, figure 2. We give figure numbers to make things easy. So in figure 1, I'm giving plotting 2 things, 211 and 212. Okay, that is the size actually. 211 first plot, and second plot on the second axis, 212. Okay, so you can have a plot like this, but since it is not very clear, but we should be having the title on the first one itself, but that's fine. Now the other plot was on figure 2. Now there is only one figure. You can see that 4, 5, 6 same plot, but now this is, there is only one figure and it is not divided into 2 parts. So it is taking its whole width. It is taking its whole width. You can see this. And I'll show you the difference. Let me show you the difference. Into, okay. What I'll do is I'll put the figure here. The 2 I already have. I'll put figure 3 here. I will just commented figure 2 and I'll make it figure 3. Okay, now you can see. Let's see what happens. You can see this. Now why it is not? Because I have given the plot subplot. This is a subplot 211. Now if I comment it further, so they will be of same width. See, 1, 2, 3. Figure 1. This is figure 1, figure 2, and figure 3. Now I can divide my figure 1 into different parts and figure 2 also into different parts. That is what we did earlier. But in this case, we won't do anything. Right? I want to finish my plot. If I may hurry up, but I'll put the text in this so that you can understand further. I'm just actually putting pasting so that I don't utilize this time in just writing my codes. So I normally do them in advance and test also. Okay, so we have two variables, mu and sigma. Mu will be having 100 and sigma will be having 50. This is how you can actually use variables in Python. You can use in other languages also like this. More than one value you can assign. Now, x is equal to mu plus sigma into random. This is just a value which is generated, right? It can be anything. We are just adding in the x-axis. Now, plot a histogram. We are putting a histogram plot. This is a histogram plot with x-axis and then y50. Density is 1. Face color is green. Alpha size is 0.75. We'll see that I'll vary the size and we'll see. Now, x label, we are putting smarts. Y label, we are putting probability. And the title is histogram of IQ. What is the IQ of a student? Okay. Then text, we are putting mu and sigma, and we'll see that. I'll just comment these two things. Now I'll just comment it and show you one by one. You can see the plot. Okay, this is histogram of IQ, probability here, and smart here. Okay, now let me copy this and then open one by one. I'll put the text now. See, I've put the text here. Mu, sigma. This is the code I have given actually for mu and sigma. So you can get this code and you can print it that. There. This is how you print. You have to put R, okay, and the data and the size 60, 0.25. Text you can put, then we can have more things. Okay. This is axis is 40 to 160, 0, 0.03. This is 0 to 0.30. This is your x-axis, this is your y-axis. Okay, and we can have the grid also. So you can change the axis. Sometimes when the plot is not good, you can always change the axis. If you think that this plot is not coming properly, then you can change the axis and see why the things are not happening the way you want. You can see now the grid. So these things you can see different ways, and just the data, whatever the data you have, you can plot. Okay, so it's nothing to do with the plot. Histogram plot, you can see the density. I can change the face color is okay. I can change this. I'll show you it here itself and see what happens when I change alpha. You can see it becomes more translucent type. 0.85. darker. So this is actually alpha dithering. It is in image processing. It is alpha dithering. You must have seen on TVs also. You have the color thing where you can adjust your alpha values. Color. It is called color dithering basically. We normally use this in image processing. Face color, green. You can put it anything you like. Different codes are there. The first letter of that can be used and checked whether it is working or not. And density, you can increase or decrease the density in Z. And if it is beyond the parameters, it will tell you. In this case, actually, there's nothing much which can be seen. Let me see if I can make it a little transparent and see if density can make any difference to you. And now let me change the density to some big value. 8. Face color is okay. It won't make much difference actually as such. Here it won't make much difference. So let it be whatever the value is. We'll see more plots and then we'll see the values which may make a difference to plot. Okay. All right. Now, this is interesting. If I want to point out something on my line plot, I'll show you first. There is a plot.subplot. We have used access. Then np.range. We have just generated a value on t and s. That is a cos value, cos theta, cos 2 pi 2 into np dot pi into t. Okay. Then the line is a line. We are putting a plot plt.plot t s and a line width is equal to 2. LW is equal to 2. Then annotate local max. See, this is line I want, and what I want here, this line. Local max. This is local max. XY 21. X Y text 3 1.5. Arrow position, dictionary, face color red, shrink 0.05. That is the width of this. So I can use line here. I can put it my limit and all that. That's okay. That's your choice. What you want to give the limits. Not sure. So you can use these two to have the line. Okay. So you can pointer, you can use a pointer to the data. And now I'll have a bigger one. And now I'll fix the random seed. Okay. Now what I've done is I am fixing the random. That is what I said. We have things to fix your random value so that whatever the value is generated, it is always the same. So random seed option we put a random seed. We took say np.random.seed and the value. Now normally what I do is I try to put the date of year of birth or date of birth of the students. So I ask the students to put their date of birth or whoever is using actually, so that the person can remember the random seed. The interesting part with random seed is if you remember the value which you have given for random seed, and when you generate the data again using the same seed, the same data will be generated. And that is actually a crack of random. So normally what I do when I encrypt a file using random values, I generate a random matrix and I encrypt using some other functionalities, some encryption techniques. So what I'll do is I'll put the random and in such a way that I remember it later on. So if I have to retrieve, I just have to put the same random value, random seed, sorry, and same random data will be generated. Using that, I can decode my image. I can retrieve my image. This is what happens. Actually, hackers also can actually detect your image because they know the sequence. It can be your, but it has to be big random seed. And what they do is they have certain codes where they will put it, and it will just mix match, and it will come out. And it takes sometimes, it takes time actually. It's not that it will just click on one go. They put it in a loop and try to figure out what could be the encryption technique, or what could be the random value which has been used. So if you know the fix, if you know the seed, if you can crack the seed, you can crack the random value, and you can actually get the image or whatever data is hidden out of that if random is used. Okay, so I normally use a seed in such a way that it cannot be detected, and if I'm using random at all, but normally I don't. I would encrypt an image using an image. Okay, I won't be using that anyway. So random seed, you can see that I've used random normalization function where I'm using LOC, that is location 0.5, scale 0.4, size is 1000, so interval of 0 1. Okay, uh, interval of 0 to 1. Okay, now y we have, then we have just used y greater than 0 and y less than 0 1. Between 0 and 1 I'm getting the data. That is what was the aim. 0 1, this is just random value which is generated, and then we are sorting it. So let me show you first what we get. Okay, what we get here, maybe big data, that's okay, doesn't matter. And then y, I'll just put everything in a comment. I can put 3 quotes and put everything in a comment. Okay, so let's run it. Okay, this is a big data, so I may not be able to see the thing properly. That's okay. What can we do? We can't do much. Okay, this comment print statement you can see one by one. When you run the code, you can see them one by one. The next axis we are generating again a value, length of y, range 0 to length of y, whatever the data is generated in y. So you can get that. Now you have a plotted figure, subplot to 1 1, x, y, linear, y scale, and title. You can put x and y. You are putting x axis and y axis. Whatever data you have for x and y, it can be generated the way you want. Then this is the linear. This is the log. You can put the log. Different plots are there. Plot xy, log, and you're putting the mean. Sim log. We have logit function. Time threshold here given as 0.01. These are the titles you're just printing. This is y minus y dot mean. So you get the log. Logit function is also there, but we are just putting the data. You can see I'm just printing the data. And you can adjust the subplots layout because the logit one may take more space. It may take more space, so you just have to adjust the subplots. So top 0.92, bottom is 0.08, left is 0.10, right is 0.95. Horizontal space, H space is 0.25 and vertical and W space is 0.35. If I don't use it, I'll show you what happens, and if I use it, what happens. This is normal plot. You will get more plots like this. The 4 plots are there. Okay, here we're plotting that, and if I don't use it, what happens? So you can see that it's okay, doesn't matter. But if Simlog is taking more space, then it will be a problem. But threshold value is already set, so it should not be. So let it be. Let's plot it. So more than one plot, and you can see that figure 1 is divided. It is 211, 222, 223, and 224. 1, 2, 3, 4. 4 plots are there, 2 by 2. You can see that plots are there. On what axis you want to print, that depends on you. Where you want to print, and you can change that also. I can give you some more of the plots. You can upgrade the matplot if things are not working. I have to plot few things, and let me see if I can use that. NumPy and all we have already called. Let's see. Sure. We have some data. We have generated again some data. N is below 5. Means, women means, mean standard deviation, men ka standard deviation and women ka standard deviation. We have put the values. Now we get the location of the group. np.range n is 5 and width is 0.35. That the width of the bars can also be length of the sequence. This is for the width of the bar plot we are having, but this is a different type. You can see that. Now P1, P2, AX dot bar, AX dot bar. So bar plot we are having. On the first one we have the men, and on the second is the women. Okay, let me run it first. Like this, men and women. Men and women. That is stacked. You can bar graph. You can say. So P1 and P2 we have created, and then plotting may horizontal line 0, color gray, line width is 0.8. Okay, this one, this gray line. Okay, so it can be anything. Now we are putting a set X label, Y label. We are putting title. We are putting then X tick labels G1, G2, G3. This also I can change. Legend I can change, and plot dot show is there. So on this one, P1 and P2 we give like this, and then we can plot. Indices IND we have given index, that is the X location of for the groups. Then men mean we already have, men women mean we have, then we have the width, that is 0.35, that is width of the bar. Then we have in bottom this men means, and here is women standard deviation, and the labels and label for men and women are there. You can see this is, you can have something like a bar, stacked bar graph. You can plot something like this. All you have to do is P1 and P2. You have to get, and then you have to put the parameters there, and you can get the plot. So data, again, it can be from your Excel file, or it can be from your generated file, whatever you want to do, you can have the data that way. Now let's generate some data. We using pandas and NumPy. Series data we are 20, sorry, generating random numbers again. It's a date wise. Starting from 1/1/2020, period is 1000. So 26 tak we have got the data. Now if I want to plot this, and first I'll have to find the cumulative sum. I want to like to have a cumulative sum of each date. So what I use is sum cumulative sum, and then I can print and see this is the cumulative sum I get. It may be the same if the variation is not there in the date. On one date, one entry is there, so from there will be no change at all. And now I plot it. Yes, we have cumulative sum. We have now. I can plot this. Before plotting, we normally find the cumulative sum. See that series is plotted. You can have January. You can see that it is already on its own. January 2010, July, July, Jan 2012. You can see that year it has already taken on its own. 2010. Date is in year, yeah, TDMMYY format. Date, month, year, but it is taking month, year first. So date plot, if you have the data something like having date in it, so you can plot it something like this. Then we can have a data frame, and then we can plot that also. We have a data frame, and data frame we have seen already. Something like this. We have random numbers, that is A, B, C, D, A, B, C, D, and the data is divided. I want to plot this data frame, I can plot that, but I have before that I have to find the cumulative sum. So if I find the cumulative sum and print it, and you can see, although it may not make any difference as such, it is a date wise. Okay, data is date wise, and you can see that we have given the date also. Where is that? Yeah, random cumulative ABCD. You can just say that. And thousands of 4 है, cumulative list ABCD है. S dot index. Index में क्या है? S dot index है. That is what from where the date has come. ये date यहाँ सही है. Index we have given S dot index. So data frame it is generated. Now I can plot. It is again a date plot. So plot dot figure you can use, and df data frame dot plot. You can use this, and you can see this. Okay, and that date you can see here. So what we had earlier, it was like this, but now it is in columns A, B, C, D. We can change A, B, C, D actually, and then you can have something like that. So let's say we have 4 categories year wise, or let's say sales of 4 products. A, B, C, D could be products also. It can be anything. It's your data, you can actually manage it. And let's take out few things from the data. Let's generate day 1 data frame np.random 102 column ABC, just cumulative sum here itself. We have given the cumulative sum here itself because that has to be found. So when we are generating this up till now, up till here dot cumulative sum, and you can find that cumulative sum is there. You can have BCD also. You can increase the size to your choice. And we don't have A here, so I want to put A. Suppose A is a class. So in a data frame, you can simply add a column by just giving the name of the column and the data. So if I run it, you can see in this A is added 0 to 99, 999, sorry. Series list range length of the data frame. Length of the data frame is 1000, so 0 to 1000 numbers are generated 1 to 3. 0, 1, 2, 3. So it could be a class or it can be your index or whatever you want to have. And then we can simply plot it. df1 here, plot x-axis and y-axis. You have to tell what is there on x and what is there on y. And since it is a label, so you can say that A, B, like this. A is on the x-axis and B on the y. So only one value is used here to plot. You can have more than one also. You can have a bar plot also. Data frame, I think I have taken that locations. I lock the integer location. Plot.figure again. Next one, the df, that is the data which we generated earlier. df.ilock. Ilock is a location, fifth location column basically, and kind is equal to bar plot. What type of plot? That is a bar plot. A, B, C, D, that is the data which was here. A, B, C, D. Ilock 5. And you can see the data if you want to. I'll show you. Print df.ilock. Integer location, you can give the location either using ilock, that is 5 data. We have just got the 5 A, B, C, D का पहला. Fifth में you can see, अगर if I am able to see, because वो भाग जाता है data. So let's see, 1, 2, 3, 4, 5, 0, 7, 9. It's not visible because it is starting from 0 to some common inside. But that is not visible. I can't show you that for now. So A, B, C, D, ilock, that is location of a row you have taken. ilock 5. And column, if you want to give, you can give simply using the header like A, B, or C. Okay. Now we have another data which we can generate. I've created another data frame, that is BF2.
So,
Yeah. Yeah.
sir, could you explain what is ilock?
Location. Integer location. Location of the row, na? Yeah, this one, fifth row.
Yes, sir.
Okay.
What does it mean? Like
In a
ilock?
data frame, if you want to access a particular row or a particular column, you give the dimension, right?
Oh, okay, okay, sir. Okay.
So you can give integer location also,
Oh,
or you can simply give the name of the column, like
okay, sir.
A,
Yeah, got
B,
that,
C.
sir.
Yeah.
We are
So better.
access.
Yeah. That is that. You can use integer location. That is why it is ilock. I can use ilock or I can use lock only. Location, LOC, and ilock is integer location. So this is another data we have generated. Then we can plot this. These are simple plots. Direct plotting, I'm just showing you how we can get the data and plot. I can use some data from the files also, but I'm generating the data and just printing it. So df2.plot.bar plot, and we can have the stacked bar. If you want to have a stacked bar, you can have a stacked bar also. You can see this one. This was not a stacked bar. This is a stacked bar. You can have a stacked bar also. So this is similar to your Excel, but more options. A horizontal bar graph, stacked, true. Horizontal bar graph, you can have something like this. H bar. Simple bar is vertical. H bar is your horizontal. Now let me generate some more data. Is using pd.data frame to convert this into a data frame. That is where actually your normally your data would be. Most of the data will be like that. If I want histogram, which we did earlier also, to plot.figure, I normally use plot.figure so that I can get a free canvas, clear canvas. You can see this. The plots ABC, and in this case, alpha size is 0.5. That is, it will be little transparent, translucent, something like this. Okay, I can change that. You know, if I change the, it will either increase or decrease. So I can make it 0.75. It will become darker, and if I decrease it further, 0.25, it will be more transparent. So it depends on you. The alpha value is on you, so you can change it to the value you want. And I can have bins also. When I say bins, so it will actually now have something like this. Start is true, one on the other. Stacking is true, and the bins are 20. You can see now that stairs you can see. So it has further divided that. And if I increase the bin, you can see what happens. 60. 80 will be too much. You can see that. Further plotting display, you can see. Now
Sir,
let's
what does stack to means?
stacked is one on the other. Here, no? Just see 1 minute here. This is stacking one on the other.
Okay, okay, yeah, okay, sir.
The classes are placed one on the other. No? That is stacking. So you can have in Excel also same plot, similar plot in Excel also stacked plot, but this is like you have more control over it. Here we can have horizontal plots. We can have horizontal stacked like this bar H, that is horizontal bar. You can have something like this. You can have stacks something like this also. This is stacking one on the other. Okay, this is because of the width actually, so it's not one on the other directly. Then you can have a histogram plot, and where we can say that orientation is horizontal and cumulative is true. So you can have something like this. But if I want to have false, then I can see the difference. Cumulative, let's make it false. This is only of one column. See, cumulative sum, like it is cumulative sum, summing up the things. This is without summing up the things. So in the plot itself, you can give, or you can find the cumulative sum of the data, and then you can do it. Then we have something like plot again. Figure again, we are clearing the canvas. Uh, Differential plot, df dot differential. You're finding of, and then you're finding the histogram plot of that. And then color is k is gray or black. Actually, alpha is 0.5, bins is 50. Now let me show you this. Let me increase that alpha size. K is actually black, but yeah, see, this is black. Okay, but if I decrease this thing alpha, let me decrease this alpha to 0.25. All the four things are columns are printed A, B, C, D, but you can see that it is now grayish in color. So it has changed from black to gray. Then we have the most interesting plots of all, that is your box plot, which we actually use a lot in data analysis, which we have already seen also. You'll realize this. See this plot we did earlier also. So this is a box plot. You can use from the data you already have, and you can actually change the colors. Different colors you can have. Let me give you. I've put all the colors. Boxes, you can say dark green. Whiskers, dark orange. Medians, dark blue, and caps as gray. And symmetry is R plus, that is red color is equal to color, and df dot plot dot box plot. Now you can see boxes dark green. These are the boxes which are dark green. Whiskers are dark orange. These are the lines. These are called whiskers. Medians are dark blue. These are the median values. And caps are gray. These are the caps. Yeah, yeah. These are the caps. And then we have sim as R plus. This is sim. Krishan Goyal. Okay. Now we can have a vertical. If I put vertical as false, what happens? And positions I can give. Now suppose we have df.plot.boxplot. Vertical is false. Positions 1, 4, 5, 6. If I plot it, you can see this. You can always change and see. There are a lot of things you can do with your plots. You can generate the data. You can change everything. 10 to 5. You can generate the data. As you can see, now I'm working more on the box plots because these are commonly used for analyzing the data. Plot.figure box plot. Okay, then we have we can generate more data. Different type of data I'm generating so that we can have different plots and see how they work. But more or less, the command is very simple. You just have to df.plot, data frame.plot, whatever data you have. This one is just a data frame that is randomly generated 10 by 2, column 1 and column 2. You can see, and the data is there. And then we have data frame X. We already don't have X here, so but X will be added if it is not there. dfx pd.series. You can say A B C D. It has to be, numbers have to be same 9, that is 10 numbers are there. If 10 values are rows are there, then 10 column rows are also here. Also 10 rows have to be there. If it is not equal, then it won't come. It will give you an error. Okay, so it is showing red, but it's okay. Now I can plot this box plot again and see what happens. Figure dot plot dot figure. Then b is equal to df dot box plot by b is equal to y. sorry, X by X. So box plot grouped by X. Okay, column 1, column 2, X. You can have a plot like this. Again, we are generating some more data. Again, it's the similar data which was earlier. Just because I have overwritten that, so generating again. This is random, so data would change. Although I fixed it, I have the option of putting and printing an area plot. I can get an area plot also, something like this. This is called a plot. DF is the data frame. DF dot plot area. Okay, this is from matplot only, and stacking is by default true. If I say stack is false, then this will be a little more transparent and you can see what is there. All right, now this is false and you can see that. Okay, so you can see the outlines. If it is not stacked, then you can see the data clearly. Simple scatter plot, I'll show you. This is a simple scatter plot, which is again used like if we are using k-means and clustering. When we are using clustering, this is the most common plot will be which will be used. So there are two things. One is box plot, the other is scatter plot, which are used most of the time. And scatter the syntax I have put above, but I'll have to clean it up and put it properly. I'll do that once I'll upload this on GitHub and share it with you all. Now, df.plotter scatter, sorry, x is equal to a, y is equal to b, color is dark blue, label is group 1. Now, df.plot.scatter, x is equal to c, y is equal to d, color is equal to dark green, label is equal to group 2, and x is equal to s. You can see that axis. Okay. So group 1 and group 2. These two are plotted, and you can see that one is green, dark green, and one is dark blue. The color. I hope it is visible. I'm not color blind. I can see. Okay. They're so dark that things are not. So if one plot is there, I'll put it in a variable s, and then the other one, when I'm plotting, I'll say that ex is equal to s, axis is equal to s, and then it will be there. So you can have something like this. Then we have the scatter with the color variations. Color bar we have something like this thing, the color bar, and you can see the difference there. Okay, x is equal to a, y is equal to b, c is equal to c. That c is the color actually we have seen, and s is equal to 50. This I explained earlier also what is s, and I've put it above also what is s, but still understand that once I'll put it. Again, we generated a new data, and we are just plotting and printing and see that this data is generated. So random data 1002, column AB, that is we are getting two columns. I'm putting in the data frame directly so that I don't have to first create the random numbers, then put it in the data frame, then I have to give the column names. So just put it directly. So, and in DF we have increased by 1000, put 1000 added to it, and print the data. You can see that. Now I'll put Hex Bin. This is something very interesting plot, a very nice plot actually. This is some similar to your scatter plot, but this is called Hex Bin Plot. Okay, colors are there, so you can have that, and you can vary the colors. Okay, you can vary the color. Grid size we have given to 25. We can increase the grid size to something else. Let's say 55 and see what happens. See, the grid size, if I increase, you can see that there will be more differing here. There will be the smaller pixels will be smaller. Increase that, it will be more clear. Hexagonal shapes are there. That's it is called hex bin. You can see that hex is the hex bin. The hexagonal shapes, so you can increase or decrease the size and see the grid size you are giving. You can see this. This is more clear. So you can vary and you can actually play around with the values and see. Okay, so by default, what I gave was 25. So you can give this also. So let me increase it. So actually, I have taken this, but I have to explain NumPy also so that you can understand it better. So there are different plots we have. We have other plots. So most important of them, you can have the stacked plot, the box plots, the scatter plot. This is again an important plot. And then we have hex bins also. This is very important plot, scatter plot. Normally when I use my data, I would get a scatter plot and see how the data is arranged, how the data is distributed. And in clustering, you have to use a scatter plot. So data can be anything, but the syntax you should know. So I'll be putting some text here, the syntax, and which is missing here because I just wanted to show you the things. And I'll put the syntax here so that you can understand what the syntax is and what exactly you can do with the syntax. So with the explanation, I'll put it and then upload it on GitHub also and here also. I'll share it with you in the class notes also so that you can actually go through it and see what all options you have. And Matplot, you can go directly to the documentation of Matplot also, but there you have many actually plots, thousands of plots are there. So but anyway, I'll share the link for that also here. Only I'll put the link of Matplot documentation on the top. So because we are using Matplot, so you should be knowing the manuals also. I normally use the manuals, so the data which I'm plotting would be from the manual only, documentation of Matplot. Okay. But we'll be applying it in real time, that is on our own data sets. This is just for the sake of example. So how you can visualize your data. Data visualization is something very important in data analysis or in anything. To analyze the data, you should actually understand the data also, right? So anyway, we'll be meeting now tomorrow in the lab, and we'll be continuing with the plots, and then I'll be taking NumPy and all, and then I'll be giving you some assignment to do so that you can apply on your data and see actually how it works, how the plotting works, and then we can continue further. Right, guys, we'll be meeting tomorrow. Okay, fine. See you.
Yes, sir. Thank you.
Right, bye.